Uh-uh. Hello, good afternoon, class and everyone. So, what a great way to start the day, my dear students. And I'd like to ask, are you all ready for a mind blowing scientific adventure? Because today we're going to dive deep within the building blocks of everything that surrounds us, from the air that we breathe to the food that we eat. Because we're about to explore and experience the amazing world in matter and in phase changes. Now, before we formally start with the lecture, I'd like to ask James Phillip to lead with a class opening prayer.
Let us put ourselves now in the presence of God and in the Father, the Son, the Holy Spirit. Our Father who art in heaven, hallowed be your name. Your kingdom come, your will be done on earth as it is in heaven. Give us this day our daily bread and forgive us our sins, as we forgive those who sin against us. Do not bring us to the trap, but deliver us from evil. In the Father, the Son, the Holy Spirit.
Okay, thank you so much, James Phillip, for leading the opening prayer. And now, with divine blessing, are you guys ready for our lesson today? Okay, so I take it that everyone's ready now. So let's proceed with our lecture. But first, let us get to know our household rules or our classroom rules. Next slide, please. Okay. So yes, our classroom rules consist of class, which means C for connect respectfully. So first up, which it means that in sharing ideas and also asking questions or even disagreeing, we do it with respect to each other's thoughts and feelings, and everyone should value everyone's perspective in class. Moving on with L, meaning listen actively. I encourage everyone to always pay attention, focus on what's being communicated. It means putting away distractions and truly engaging with the class, whether it is with me or with your classmate. Then we have A for act responsibly, meaning that we have to be prepared in class. We need to take ownership for our learning and being mindful of the classroom space and resources. Next up, we have as for stay focused. We all know that there can be a lot of interesting things our eyes are vying for attention, but let us know that we're on a class and let's try our very best to engage with the task at hand. And last, certainly not the least, is that we have as for speak kindly. Our words have power, so we want to build them up for each other and create a positive classroom atmosphere. Now, everyone agrees with me with this classroom rules. Okay, thank you. So, since you're with me so far, let us get to know our learning objectives first. So, let me present the next slide. Okay, so lesson objectives. So, first up, we must identify, or I mean, students must identify and describe the three common states of matter. Next up is to be able to explain the particle arrangement and movement in each state. Next up is to define and provide examples of the processes of phase change. Next up is to differentiate between physical and chemical changes. So are you with me so far? Okay, so next up, now that we know what our objective is for today, let us now find a way on how we can achieve those. So I will just be doing a very quick review. This will just test your prior knowledge with the lesson. So I'd like to call it What's the Matter? So I will be presenting quite a few questions on the screen, and I'd like to ask some of you to answer or share whatever thoughts you have. So first question here, next slide please. So question first is, what are the three common states of matter and how are they different from each other? So anyone who has an idea, you can just share at least one. Yes, James Phillip.
Hello, ma'am. So, the three common states of matter are the solid, liquid, and gas, and they're actually differentiate based on the molecules. the distance of their molecules, and how they are arranged together.
Oh, okay. So yes, that's good. That's a very good start. That's very precise. So thank you for answering. Next up, I have here the next question. Next slide, please. Okay. So why do solids have a fixed shape while liquids and gases do not? So aren't you all curious why it has a definite shape? So anyone? Yes, Christine. Oh, okay. Yes, exactly. So that is the correct answer that they differ with the structures or the particles that they're made of. So thanks for sharing. Now let's move on with the next question. So here, how does temperature affect the state of a substance? Does anyone have any idea? Ah, yes, Philip.
For me, ma'am, how does temperature affect the state of substance is because of how it's based on the behavior of the molecules when they're interacted with different or various temperature intervals. So basically, the molecules will react to the temperature and they will start moving. And there is actually a theory of that. And yeah, that's all.
Oh, okay, perfect. So that's really good. What a brilliant mind you have there, Philip. So that's very well said. And I think it's getting too exciting. So before we get to that, let me present the next question. Okay. So any one of you can name a material at home that is solid, liquid, or a gas. And what do you think happens when they are heated or cooled? Yes, Christine. Oh, okay. Yes, that's a very great observation you have there, Christine. Very insightful. So then we're coming off as strong. Let me present a different question here. Okay, so what about this? Since Christine has already shared her observations in the kitchen, what other examples of phase change can you observe in your daily lives? Okay, so yes, anyone you can type in your yes, Philip.
For me, one of the examples of face changes is kanang sublimation ba when I was like we have like kanang ganing murag albatros ba, and then I noticed that it will sublimate easily without any contact with water or anything. It's just automatically transformed from solid to gas. Ganun.
Oh, okay, yes, what a very keen observer you have there, Philip. That's good. Thanks for sharing. And now let me present another question. Mhm. So what do you think might cause water or other states of matter to change from one form to another? So I think that has been answered. Know that it's about temperature. So temperature has something to do with the phase change. Let's just proceed with the other slide. Okay. So there we have four matters. So I really appreciate you for sharing all the ideas and thoughts you have. Thank you. And now let me present a different activity because we're still not done. Let me see. Okay, so I have here on screen with me a puzzle board wherein I'd like you to search for anything that you can find on the screen, something that relates to matter. So you can just type in your answers on the chat box. Okay, so I will give you at least 3 minutes to search for the words and type in your answers. Okay, so yes, that's condensation, correct? Okay, so yes, thank you so much everyone for searching that. Yes, Christine, that's correct. Solidification is part of those. So then I hope that you have enjoyed this little activity. So now with the words that you have looked or searched, here are the answers. Next slide, please. Okay, so the answers to that is that there's actually 16 words. Part of that is solidification, evaporation, melting, steam, and whatsoever. So those are the words we can find in that puzzle. So thanks everyone for taking the time to look into it. Now let's proceed with the next slide. Okay, so our little activity is not yet done as we're still about to get to the exciting part. So I'd like to call this next activity as Mother Hunt. So I will present on screen pictures or examples, and I need you to determine what are those. So next slide, please. Okay, so actually, I have prepared some little a game wherein we'll be looking into different stations, and yes, there are examples. So I need you to look into it and find out what the item is about. Next slide, please. Okay, so what are these on the pictures? Anyone? Ah, yes, Christine. Oh, okay, solid. Let's find out. Let me see. Next slide. Okay, you got that right. Perfect, Christine. That's solid. Next slide, please. Okay, and what about the second station wherein it shows this picture? So, anyone would like to guess? Yes, Philip.
Based on the picture and how is it related to on a daily life basis, I guess they are referring to gas.
Oh, okay, gas. Let's find out. Let's see. Okay, so yes, that's correct. Perfect. That answer is gas. Now let's move on to the next slide. Okay. So third station is we have here particles and matter. So what is this, Christine? Oh, okay, liquid. Let me see. Slide. Okay, so yes, that's a liquid, correct. Thank you. Next slide. Okay, so on to our fourth station. And let's see. And what about this? Anyone who has an idea? Yes, Philip.
That's a process called sublimation, ma'am.
Sublimation. Let's find out. Let me see. Next slide. Okay, so yes, that's exactly sublimation. Thank you. And what about this next one? Okay, so down to the fifth. Anyone who has an idea what this is? Yes, Christine. Condensation. Let me see. Let's check. Okay, so yes, that's exactly condensation. Thank you. And the next one. Okay, down to the sixth one. Oh, I think it's the answers are on the screen. So anyone? So I think that's very visible now from the picture itself. That's evaporation. So the next slide, down to the seventh station. So what is this? Philip?
I think it's melting. It's a process called melting from solid to liquid.
Oh, okay. So let us see. Next slide. Okay, so yes, it's melting. Perfect. And I think we're down to the last part, which is our eighth station. So, okay, next slide, please. Oh, what is this? Okay, yes, Christine. Okay, freezing. Let's check. Okay, so yes, that's perfect. So it's called freezing. Thank you so much for sharing, everyone. I hope you enjoyed our little activity today. So let's move on with the next slide. Okay, so what is matter? Next slide, please. So in here, we're going now that I know you have enjoyed our little activity, but let us first discuss what matter is. So what is matter? So initially, matter is anything that has mass, it takes up space, and also it has a volume. And another thing is that matter is actually made up of atoms, which consist of the three particles, which is a proton, neutrons, and electrons. And now with the main stages or states, we have their solid, liquid, gas, and plasma. But we will not be discussing plasma because it's out of our scope today. We'll only focus on the three main parts, solid, liquid, and gas, and they actually differ from each other as what you have recalled. James Phillips said that it differs with the particle arrangement and behaviors. And next up is that matter has an observable and measurable properties such as again mass, volume, density, and color. And rule of thumb is that matter cannot be created or destroyed. It can only be changed from one form to another. So in short term, it can only be transformed. And another thing that most people overlooked too is that energy, light, and sound are not part of matter because they don't have the qualities or possess any mass or volume. Okay, so are you with me so far? Okay, so then next up, we're going to briefly discuss what a solid is. So again, solids have a closely packed particles held in place by strong force, with vibration being the only motion felt. And yes, they have a definite shape and volume. And most solids are actually crystalline in form, which is a structured atom order, which is on the faces. Solid has the most definite shape and mass. So now let's proceed with the next one. Okay, so now that we know what our solids are, as you can see from this picture at my left side, there is a moving particles, but the particles are not so close with each other, so they still have a room to move freely. And liquids, with that being said, liquid flow freely and it adapts to the shape of its container and will almost have a fixed volume. And they are very slightly compressible and form when a solid is melted through or with enough pressure after being heated above its melting point. So I hope you get what liquid is now. Let's proceed with the next one. So we have our gas. So gases contains particles of high kinetic energy that float around freely. They possess neither a fixed shape nor volume, and they can fill any vessel. So if you can see on the pictures attached, the particles are actually moving freely and they're far away from each other, which means that they could take up as much space they needed and they can fill any container or any vessel. So let's move on to the next slide. Okay, so there we have, since we already know what our matters are, let's proceed with the topic of phase changes. Next slide, please. Okay, so phase change. Anyone who'd like to read what's on the screen for phase change? So I'd like to ask Philip if you can read what phase change is.
Okay, ma'am, so a phase change is a form in which a substance exists. On Earth, the different states of matter are solid, liquid, gas, and plasma. Each form of matter has unique properties, including specific heats, melting points, and boiling points. Under certain conditions, different phases can coexist. There are 8 thermal processes through which matter can attain phase change. They are melting, freezing, evaporation, condensation, sublimation, deposition, ionization, and recombination. These 8 phases exist under different temperatures and pressure conditions.
Oh, okay. So yes, thank you so much, Philip. I appreciate the effort. Thanks for reading. And now let's proceed with the next part. So since we know what phase changes is now, as per Philip, so let's try to break down the common phase changes that we encounter in our daily lives. Starting off with melting. As you can see on the picture, there is an ice cube that melts. So let us know what the process is. So melting is from solid, it transforms into liquid. And when a solid is heated, its particles absorb energy and begin to vibrate more rapidly. And when energy is absorbed, it is called endothermic process. And as a result, at a specific temperature, called the melting point, the solid structures begin to break down and it becomes a liquid. So when temperature is added, the particles get excited, so that's why it detach itself from one another, so causing to leave more space or an open room to have a new substance created, like from solid to liquid. So I hope that you get that part. And now let's see the next slide. Okay, so freezing. So what is freezing? I'd like to call Christine to read what is on the screen. Oh, okay, thank you. Thanks for that, Christine. So, right, you can see that when a particle, or I mean, if an energy or heat leaves a particle, it leaves room or an open space to have the energy absorbed. So that's why you can see that on the next, or I mean, on the image, there are shards of ice. So that is from liquid water to solid, which means ice. So thank you for reading. Now let's proceed with the next part. Okay, so vaporization, I'm sorry. So vaporization is a process from liquid to gas, which means heating a liquid gives particles enough energy to break free from the liquid's surface. And there are different types. So what happens in boiling? So boiling, it means that it has reached the boiling point of a liquid and evaporation happens at the surface below the boiling point. So as you can see on the image, the there is a pot with water inside it. So once it's heated, it reacts. So with that being said, the water evaporates and it causes gas or air to release from its surface. So I hope that you're still with me as we're still about to discuss another thing. Let's do the next slide, please. Okay, so condensation. Philip, I would like you to read what condensation is.
Okay, ma'am. So condensation refers to when a gas particles cool, they lose energy. Energy is released through exothermic process and move closer together. Gas becomes a liquid at the dew point or condensation point.
Oh, okay, so yes, thank you. So that's condensation. And as you can see that on the picture, there's a water, but outside its container, there's a dew point, which is the condensation point. And I hope that you get it as we're about to discuss the other one or the next slide. Okay, so we have here sublimation. So sublimation is a process of solid to gas, and some solids gain enough energy for particles to escape directly into the gas phase without becoming a liquid. So this is what James Philip has observed, sublimation. Okay, so you can see that from solid it releases gas and it transforms into a different energy type. So now let's proceed with the next one. Okay, so now that we know what our matter and phase changes is, does anyone knows what is the connection with phase change to temperature? So I'd like you to answer and a general term or form, or if you'd like to explain whatever is on the board, then feel free to do so. Oh, okay. So, yes, everyone, I'm really sorry about the delay, and I apologize for the technical issues or discrepancies we're encountering today. But I hope that you are still with me. So, anyone, are you still there? Okay, so yes, thank you so much. And now that we are back, let's continue where we left off. So with this slide, temperature. So anyone who has an answer of how it relates to phase changes or how it affects the phase change, as what we have discussed earlier. Okay, yes, Christine. No need, but if you can just answer in a general term or form. Or if you'd like to explain whatever is on the board, then feel free to do so. Oh, okay. So yes, that's actually a very good observation you have there, Christine. Thank you, and I appreciate the effort and time for looking into the answers. So you are correct with this diagram shows that temperature has an effect in phase change, and it plays a very important role as some of the phase changes have certain melting and boiling points, or it has some types of pressure and temperature it applies to. So, and as you can see on the diagram, the letter B, so it has there that when a certain state reach into its point, then it will cause a change with the substance. So, again, from solid to liquid, and then liquid to gas, and then it's just a repeated cycle. So, just take note that temperature is actually constant. So, thank you for sharing your ideas. Let's proceed with the next part. Okay, so I think we have covered those on enough. So let us try to check what are the physical change versus the chemical change that applies to matter. So next slide, please. Okay, so allow me to explain what a physical change is. So, physical change is an alterations in the physical properties of a substance, such as shape, size, state. For example, solid, liquid, and gas, or temperature without changing its chemical composition. So, for example, melting ice. So it is just a physical change because we're not changing its substance, so it's still a liquid. So it's still liquid. It could be liquefied or a solid object. And then boiling water is still water, so it's still physical change. Chopping wood. So although wood is chopped, it would still have the same composition. Next up with paper, so tearing paper, paper would still remain the same, and dissolving salt into water. As we all know, salt is actually made up of water substance or particles. So then, characteristics of a physical change. So the substance remains the same; it's just in different form. So many physical changes can be reversed by reversing the process, like freezing from water to ice or melting from ice into water. So there are no new substance formed. An example to that are yes, melting, solid to liquid, ice to water, as per mentioned earlier, and then freezing, liquid to solid, water to ice. Then we have evaporation from liquid to gas, so water to steam, and then condensation, gas to liquid, or steam to water. So, anyone, does that make sense? Okay, so yes, thanks for responding. Now let's proceed with the next part. Okay, so chemical change. Now, to explain this one, allow me to read its definition that chemical change is a result in the formation of new substance with different chemical compositions and properties. For example, burning of woods, roasting iron, baking a cake, and digesting food. So its characteristics consist of a substance that is chemically or identify is changed and a new substance is created. And chemical changes are often difficult or impossible to reverse, as usually energy is involved, so it is either absorbed or released. So, one of the examples for chemical change is combustion. So, a rapid chemical reaction that produces heat and light, for example, burning, and also, we have corrosion and decomposition, but let's not dwell on that too further because again, it's out or it's limited to our school. But I hope that you can see the difference between chemical and physical change. Let's move on with the next slide, please. Okay, so I have here created a columns about the difference of physical and chemical change. So I hope that you have taken your time to review this as we're going to discuss it furthermore. So next slide, please. Okay, so there we have. I'll be opening the floor to anyone who has questions. So let's have a little Q&A for this session. So next slide. Okay, let's just wait for it to be presented on the screen. Next slide, please. Okay, so I'd like to know from anyone who can share their ideas that how do particles behave differently in solids, liquid, and gas? And why does it affect the shape and volume of each state? So anyone who'd like to share their ideas? Ah, yes, Christine. Oh, okay. So, yes, thank you. Thanks for sharing. That's exactly what is being discussed. So, thank you. And now let's move on with the next slide. Okay, so I have here prepared a different question. So, yes, I think Philip is here now. So, are you still with us, Philip? Okay. So, would you mind reading the question on the screen and share your thoughts or answer?
Okay, ma'am. So the question is, why is burning wood considered a chemical change while freezing water is not? How can you prove new substance was formed? So for me, ma'am, is burning wood is considered chemical change because the process is actually irreversible. Meaning, di na siya mabalik sa iyang original nga state, no? Because na-change naman ang iyang um, physical appearance. While sa kaning freezing water is, it's actually a cycle man good. We need to consider it's a cycle because even though that a freezing water is not is does behave differently, but it always goes back to its other forms such as freezing. You can just like kanang maka-use ra kag other factors in order for you to have it back pa. Like you can use temperature for you to, for example, you need to freeze it. You need a freezing temperature to freeze your substance or the liquid, or you can heat the water, the solid liquid as ice to make it into a liquid. Nga na po siya. Thank you.
Oh, okay. So yes, yes. Thank you so much for sharing your ideas, Philip. And that's correct. You have observed very well and listened attentively to the class discussion. So thank you. Now, how about this question? Next slide, please. Okay. So I think this is the last one that I have asked for you. So, yes, Christine, would you mind answering and reading what's on the screen? Mm-hmm. Oh, okay. So yes, thank you. I really appreciate the effort to look into the ideas and also looking for videos about this. So thank you, Christine. That was very insightful. So then let's move on with the next slide. Okay, so then there we have it. We're already done with our discussion proper, and now let's have some games. I'd like to call it Truth Under Pressure, the Matter Challenge. So I have here a challenge for you. I will be presenting flashcards on screen. So there will be a word and a three choices or options wherein one is a lie and two are actually correct. So if you're ready, let me present the first one. Okay, so solid. Among these choices, which of this is incorrect? Okay, so anyone? Okay, so Christine. And also, I'd like you to read the word and also the one that is incorrect. Oh, okay. So yes, thank you. Thanks for reading the flashcards. Now let's present the answers on the board. Okay, so Christine answered B, and Christine is correct. So, solid, that's letter B, which is the lie or the odd one out here, the choices. So let's proceed with the next part of our word game. Okay, so physical change. How about Philip? Would you like to answer this?
Um, the choice choices ba na, ma'am? Ay, no, no, no. Okay, so the first statement would be, solids keep their shape unless forced to change. Physical change do not change a substance identity. And last but not the least is the rusting nail is a physical change. I think the lie to that statement, ma'am, is the letter C. Rusting nail is a physical change.
Oh, okay. So let's find out if you're correct. Let me see. Okay, so yes, that's perfect. What a very observant attitude you have there, Philip. So that's right. C is not an example of physical change, so it's a lie. We'll definitely cross that out. And let's proceed with the next slide. Okay, so melting. So which of these options are incorrect or is a lie? Okay, so yes, Christine. Oh, okay, so let's find out. Let's check the answers. Okay, so yes, that's perfect. So C is definitely a lie. So we're coming off strong with our activities. Appreciate it. Let's get down to the next slide. Okay, so what is condensation? One of here is a lie. So anyone who'd like to answer? Yes, Philip.
I think one of the statements the lie is the letter B. Dew on grass is an example of condensation.
Okay, let's check it out. Let's reveal the answer. Oh, okay. So I'm sorry to hear about that, Philip, but I guess the odd one here is actually C, as condensation does not require adding heat into gas. But let's check. Okay. So we will get back on it later and discuss about condensation. But now let's continue with our activity. So how about this? Okay, so now you know. So what about chemical change? Anyone who can determine which of the statement is incorrect or is a lie? Okay, so yes, Christine. Okay, so let's find the answer. Okay, so yes, that's correct, Christine. So the odd one here is B. As chemical changes, it is hard for us to reverse. It has an irreversible process. So let's get down to the next slide. Okay, so sublimation. Which of these options are incorrect or is a lie? Okay, so anyone? I mean, let me see. If no one's gonna answer, then let's try to guess what the answer is. Let me see. Okay, so you're thinking. So let me check which of these. Okay, so yes, Philip.
I think one of the lie is water vapor sublimes into ice.
Oh, okay. So let's check if that's correct. Let's see for the answer. Okay, so yes, that's perfect. Thank you, Philip. So the lie here is letter C. Thank you. And now let's get down to the next part. So evaporation. Anyone who can answer which of the statement is incorrect or is a lie? Okay, so I'm actually not hearing anyone here on the line with me. It seems like, yes, Christine, are you still with us? Oh, okay, so let's find out and see for the answer. Let's reveal the answer. Okay, so yes, that's correct. The odd one here is letter B. So thanks for sharing your idea. And now let's get down to the next slide. Okay, I think this is the last one. Chemical reaction. Anyone who would like to share whichever statement is a lie? Yes, Philip.
I think the statement that is a lie is letter A. Chemical reactions always needs heat to occur. Well,
Okay, so let's check. Let's find out the answer. So, next slide, please. And yes, Philip, you're correct. That's perfect. So, it's a great answer. And now let's move on to the next slide. Okay, so how about this reversible versus irreversible process? So, which one of the statement is a lie? So, yes, Christine. Oh, okay, so let's check. Okay, so yes, that's correct. That's true. So, I think we're down to the last part. Next slide, please. Okay, so this is the last one, guys. So, if anyone can answer, or I mean, if no one wants to answer this question, then let's just reveal the answer, and whichever is a lie here. Next slide, please. Okay, so let's find out. So there are signs of chemical change. The color change can be a sign of chemical change, which is true. And bubbles forming during boiling is always a chemical change, which is true as well. So the odd one out here is letter C, which is a new odor or gas may indicate a chemical change. So it's a lie. Now let's proceed with the next slide. Okay, so I now open the floor for any questions or any violent reactions, or if none, then I'd like to ask anyone to share their thoughts about this lesson. So, did you all enjoy the topic? Was it exciting, entertaining? So, anyone who'd like to share their experience with this lesson so far? Oh, okay. So then I take it that everyone gets the. Okay, so how about Philip? I'd like to hear, okay, no questions for me. So then I guess that's it. If there are no questions, then I'm assuming that everyone here already gets the topic and have somehow learned the lesson and has gained valuable insights about this lesson. So I really appreciate everyone for taking the time to join our class here today. And just a few reminder that there will be like an assignment uploaded into our Google Classroom to which you can visit that and review and also answer those questions asked. So then I guess that's everything for us today. So at, that already ended our topic today. So thank you everyone. I appreciate your time in joining and thanks for your effort. So okay. If there are no questions, then I'd like to say that our class is now dismissed. I hope that you are doing fine and enjoy the rest of your day.